On graphs, you have to understand how to do it with word problems. So I'm going to read the word problems and we're going to figure out how to write them in linear inequalities. Okay, an elevator can safely lift 4,400 pounds at a construction site. If the construction workers weigh on average 155 pounds and concrete blocks weigh on average 40 pounds, write an inequality that could help us find all the possible combinations of workers and concrete blocks that can ride on the elevator at one time. So obviously you don't want too many people riding on the elevator or else it will not work and it'll fall, and that's scary. So they have to make sure that we have a nice balance. So if I'm trying to equal 4,400 for my elevator, can I be smaller than that number or bigger than that number?
Smaller.
I have to be smaller. I can't be bigger or the elevator breaks. So I have 4,400 and I need it to be the biggest number possible. I need that to be as big as we get, which means that the rest of my equation is going to be smaller. It's going to have the little small part of the inequality symbol facing the rest of the equation. Can I put the or equal to underneath this?
Oh. You can.
I could. You could be exactly at 4,400. It would make sense to not do that, to just go ahead and be underneath, but you could technically. Okay, so then it says that we have 155 pound people and 40 pound concrete blocks, and the LBS means pounds. So let's just use P for people and C for concrete blocks. Y'all okay with that?
Sure.
All right, so I'm gonna write 155 P plus 40 C. And that is our inequality. That is how we write the inequality, and we're done. We could go graph that using AX plus BY equals C if we wanted to, but we don't have to. Okay, the sophomore class is planning a picnic. The cost of the picnic permit to use the city park is $250. To pay for the permit, the school will charge a fee for each sophomore for 75 cents. That's a really small fee for sophomores. And then $1.25 for any guest who is not a sophomore. Write the inequalities. Sophomores are X, other guests are Y. So if I'm going to pay 75 cents per sophomore, or I guess it's X, right? And $1.25 per guest, I need it to equal $2.50 to pay for that city permit. I need to figure out what inequality I'm going to put here. So it doesn't have to be equals, it needs to be either greater than or less than or something like that. So, what do you think?
Oh, the left side has to be greater than 250 or equal to?
Okay, the left side, so over here, has to be more or equal to 250 for us to be able to pay for that permit. So I'm going to put the alligator mouth, as people like to call it, facing the actual equation. All right, and last one. A science club is having a car wash to raise money. They will charge $5 per car and $10 per truck. Write the inequality that could be used to determine how many cars X and how many trucks Y could go through the car wash to, I didn't put a SH, to reach a goal of 120. So we're going to have $5 per car, which is X, plus $10 per truck, which is Y, and we want it to reach a goal of 120. So again, we still need this left side of the equation to be bigger than or equal to 120 to reach our goal. And that is how you write inequalities from word problems. And as a quick review, we're going to talk about functions really quick. We're going to circle all the ones that are functions and X out the ones that are not functions. Can you guys help me out figuring out which ones these are? How do you know if a table is a function or not?
A vertical line test.
A table. The vertical line test does work, but we're going to use those on the graphs.
If X doesn't repeat. It's
Okay,
a
X
function.
doesn't repeat. So I'm going to look at all the X's. It says 1, 2, 3, 4, 5, 6. Is it good? All right, I'm going to circle it. I'm going to look down here. 4, 4, 5, 5, 6.
That's not a function.
That is not a function because the X's repeat. We don't care about the Y's. For mapping, you have to have one arrow from each X. If X has more than one arrow coming from it, it's not good. Is this a function?
Yes.
Yes. It might have tricked you up because the 8 had 2 arrows going to it, but the Y side, this is the Y side, this is the X side, this does not count. It doesn't matter. So 4, 5, 6, 7, 8.
A function.
A function. Vertical line tests, like Derek said, if you draw a vertical line anywhere, it has to go through the graph only one time. Even when it gets really steep, it technically only has to go through, it can only go through once. Did all those vertical lines make the test, or
Yes.
pass the test? Yes, so this is a vertical line, or is a function. What about this one? If I draw a vertical line anywhere, what's gonna happen?
It's gonna touch it twice.
It's gonna cross twice, which is not good. Down here, if I draw a vertical line anywhere, it's only gonna touch it once. Doesn't matter where I draw my vertical line, even if it gets really steep, it's only gonna touch it once, which makes it
A function.
a function. And then I look at the x values, like you told me earlier. I have 1, 2, 1, 3, 4, 5. What is that? Not a function. Kind of tricky. It is a vertical line.
So it's not a function.
It's not a function. We don't want vertical lines to happen. And then over here, is this a function or not?
No.
Why?
It's 2 on 5.
2 on 5. Good eye. Okay. That is our video. Thank you to my helpers, Derek and Ethan, my cameraman Jaden, and my audience Addison.